Let's talk about interior illumination, and this includes both light control at the light source and also illumination using luminaires. So first of all, with light control, the initial thing you need to consider when you're talking about light bouncing around in a fixture is how exactly are you going to control that light? If you don't have a bare lamp just hanging in the center of a room, you're going to have some kind of housing or reflector or refractor around it. And their book mentions a number of different kinds of ways that materials reflect light. A specular reflection is basically just a mirror. It reflects immediately and in the exact opposite angle the light that arrives on that surface. You can have semi-specular, which is something like a brushed aluminum, or a diffuse reflection, which is a matte surface. You can also have surfaces which allow light to pass through it or not. And again, we have seen examples of these in class. Now, some light sources use special lenses. In this case, this is showing how the lens, typically glass, but it can be plastic, can force the light to focus in different directions. And of course, we use this to help us aim lights. And the great example of this is what you see in, say, a lighthouse where you have what's called a Fresnel light source. And in fact, these Fresnel lenses were popular, particularly in downlights when we didn't have quite as much industrial, expertise to get light source luminaires that had better light distribution. You just used a glass lens to spread the light out. Now, when we got that industrial ability, we were able to produce parabolic reflectors. Now, a parabolic reflector, as the book mentioned, has this unique characteristic, which is that it offers you a tremendous amount of light control when you have a point light source, typical of a filament, but also, to a lesser extent, LEDs. And even when you have a fluorescent lamp, you can get parabolic light control, and those are often used as baffles. So, and what I mean by all this is if you kind of slice through the fixture and diagram out where the light is going, you can use that calculation to get a distribution of light, which is either more horizontal than down or more down than horizontal, or one that is adjustable. So when you have things like adjustable fixtures or even just parabolic lenses, you're going to want to use a number of different things to help shield that light source from view. Now, this is particularly prevalent in things like a track light, which is adjustable, so you have the risk of these light sources pointing at your eyes. And there are baffles, which is basically a single shield, a louver, which is a series of baffles, typically in opposite directions. They call that an egg crate louver, by the way, if it's in something like an elevator is a common thing. But there are other things, cowls and shades. Those all perform a very similar effect. And the shielding angle is what these are all working on. So if you understand that our field of view is in a particular direction, you can essentially calculate that field of shielding angle, which is about 45 degrees. And even in things like recessed luminaires that are up in, say, a cove, you can calculate where the eye height is. We know, because we know how big people are, more or less, at least the range. And then we can figure out what the cutoff angle is going to be. Now, some fixtures, such as theatrical fixtures, are going to have their own little cowls. This is known as a barn door fixture because you can open and close them like barn doors. And you can actually get a pretty precise cutoff on your light source. And these are also great in situations, say, retail, where you have these adjustable lights. You really want to make sure that they are properly baffled. These don't lose any light coming out of the fixture, but they really do cut off those angles. But there are other options too. You can just snap on lenses of any number of different types, and each of these has a different effect. Of course, colored lenses are less common nowadays, but infrared lenses are common because you want to keep infrared off of materials. So what about the luminaires themselves? Well, there's a lot of different kinds of luminaires, but if we want to kind of classify them all, basically there are different types of mounting in addition to what they do. So decorative versus wall wash and whatnot. But the type of mounting is kind of the biggest differentiation: recessed, surface, suspended, or pendant mounted, and then what we tend to call architectural lighting. So suspended luminaires, they can have quite a lot of different light distribution. So we need to look at what's called the polar candela distribution curve. And as we have seen in our tours, some are basically all downlights, but suspended luminaires have the most complicated possibilities because you can have up and downlight in varying percentages. So these polar candela distribution curves will tell us, will show us what the light distribution is. It's essentially a section cut through the fixture, and it shows how much light comes down versus up in every different direction. So if you're right below the fixture, here's the fixture at the intersection of the two axes, you're getting a lot of light right here underneath it. And if you're 30 degrees away from the center line of the fixture, you're still getting a lot of light. However, once you get to 50 degrees, you're not getting anything. And what that tells us is that that's got a really good cutoff angle. Now, this one, it's all up. And again, what this is telling us is the light is going up. And in fact, this shape of light distribution is called a bat wing. Looks vaguely like bat wings because there's a lot of light coming out in this direction. Now the reason that is if this was trying to wash a ceiling with light, you wouldn't want it to be too bright right above the fixture. So they've actually designed the luminaire to spread the light, to throw more light sideways than up. And that will give you, when it lands on the ceiling, it will actually give you a very even light. Then you get into a whole messy world of up and down lighting. You can have a little bit up and a little bit of down, and you can get these in any number of configurations and percentages. Some of them are essentially a half bat wing. What this does is it sends light only sideways. And this is great if you wanted to, say, wash a wall. So it's just a matter of choosing the fixture that works best in your situation. Now, downlights are ones that we use all the time in our renderings and in our designs. And sometimes they're referred to as hi-hats or cans. There's a lot of different ways people refer to them. They are most typically round or square, but you can customize those. It basically is a hole in the ceiling, so it's whatever you want. And the finish on the rim can affect the efficiency of the luminaire. We can get, for example, interior rims around the reflector that are much darker. That can often reduce the brightness at the fixture if it's a deep enough fixture. So, and basically these are very simple fixtures. It's a can. They can be mounted in any number of different ways. And often, as in this A19 fixture, there are these parabolic reflectors. In this case, it's actually a double parabola, and that offers even greater control with that particular light source. This one uses a silver bowl lamp and is meant for things like a basement where there has the potential for a lot of glare. It still acts as a downlight, but the silver bowl effect helps you to keep the glare down from that low ceiling height. You can even use compact fluorescents for these. Again, they look a little funny, and compact fluorescents are never real efficient. So here are a couple of examples. Here's one with a dark rim. This is the trim ring out here. Typically these are white. Look, they even painted over it. How nice. But they can be really any color, and it's entirely an aesthetic decision. And of course, popping them into your projects and then forgetting about them is actually not always going to serve you real well. Choosing ones that have an interesting look to them, even this one which has a kind of reflector on top of it. This is an LED light source, so it's going to be really bright if you don't spread the light a little bit with some plastic. But you can do other things. This one's a glass one that makes an interesting reflection, or even stainless steel for that added bling to your project. So the other thing to consider is using a luminaire that is meant for its location. Sloped ceilings are the classic example. If you put a regular downlight in a sloped ceiling, it will be facing sideways. It will be facing at an angle. So be careful about that kind of stuff. Also, pet peeve of mine, don't put a downlight over a bed. Again, you think about how people use the space. In this situation, downlights are fine, but over a bed, not so nice when you go to lie down. And in this case, getting those downlights over the table, I do worry that the sort of center line of the downlights over this table are working fine, but the ones which are on the outer edges of the table may actually be right on top of people's heads. And that's definitely a no-no. People look funny with lights right above their heads. They may be adjustable, though. Speaking of adjustable, there are what are called adjustable accent lights. Those can be recessed. They can have round or square trim or no trim at all, fully recessed, projecting. My favorite company for these is Urco. It's a German company. They use all LED, super efficient, and they have an amazing array of light distributions, not just a boring old square or a circle, but squares, elongated squares, and some are recessed, some are surface mounted. And some, actually Urco I don't think makes any of these, but some are like this one where they are commonly referred to as eyeball fixtures because they kind of stick out like a bulging eyeball, I guess. And the hook arm at the top of this indicates that this is an adjustable fixture, and it can spin around in addition to rotate up. So you can really get from this one recessed fixture quite a lot of possibilities for where to aim it. Other options are things like this, where you essentially have a track fixture mounted inside a recess with a trim ring. And these are often sold as single luminaires that are installed essentially inside a box up on your ceiling. Now, each of these fixtures, again, depending on what you want to do and how much adjustability and precision you need, you can get them in any number of flavors, including parabolic reflectors, which are better for wall washing, or very tiny tungsten halogen adjustable spotlights with lenses on them, which are great for lighting small pieces of art, such as sculptures. Now, what do each of these look like? Again, when you have an adjustable light, you want to make sure that the luminaire itself is dark enough and has enough baffling ability to keep you from seeing that bright light source. And here's a gallery. I think that the photograph actually does show a bright spot right at the center of the ceiling, but the ceiling is high enough that we are not really bothered by the whole bright area. But you can see that the paintings do appear to have pretty even blobs of light on them. Or even in a situation like this, choosing a square luminaire over those countertops with a very narrow sort of light output, narrow angle for that light output, gets you really nice lighting on the countertop, not on people's heads, and it also creates a certain sense of visual hierarchy. So there are a few other flavors of these things. We saw these in class. I thought I'd just show you. Step lights are always fun. You can find little spots to recess these in. These are a really complicated detail often, especially if they fit under the nosing or in this case at the base of the riser. And some of them, like these exterior ones, are a lot easier to detail because they're just kind of applied. But again, they have an aesthetic impact. So what about the ones we see pretty much everywhere, Troffers? Now, typically they are fluorescent, although I may have mentioned that they very frequently now are just they use LED linear sources. So there are a couple of different basic flavors. There's the lensed flavor, which is kind of an all-purpose flavor, and a lens spreads the brightness of that linear source out a little bit. They're kind of cheapy. the ones which we think are as being more architectural and tend to reduce things like screen glare, those veiling receptions, those are the parabolic ones. And so if you look inside that fixture, in this case, we see a two-way baffling system. An egg crate louver, essentially, is what it is. And it's a parabola in both directions. That does lose a little bit of light bouncing around in the fixture. However, you do have a high degree of efficiency and a very nice amount of baffling. Finally, there are ones that are called volumetric, or up-down lighting is another common name for it, where the light basically kind of shines up onto a reflector and then comes down. And that's a so-called architectural look. I don't know if that's entirely true. But anyway, here's a section through a parabolic lamp, and you can see there's a vaguely parabolic shape to this downlight. There also, interesting enough, is a slot along the edges. You often use fluorescent troffers in conjunction with a plenum return. Plenum return is when the area above the ceiling acts as a giant dusty duct, and so the light can actually, or the air can seep up through these corners of the light fixture and up into the plenum and then return back to the HVAC system. Not all luminaires work that way. At our art center, we have a ducted return. You can see it by the grill up in the ceiling. So, and this is actually from the book. This is a photo of the office of the author. In fact, there's my desk right there. And they use a parabolic downlight that is pendant mounted. So very nice, good optical control. This photo's from probably 1987 or so. The architectural light mentioned, the up-down light, has a linear light source, but the light goes up from that light source and bounces off essentially a parabolic reflector. And those look kind of like this, with they do have pretty even brightness, low glare, and a fairly high efficacy. Even with all that reflecting going on, they can look pretty nice in a room. So suspended luminaires can be kind of up or down lights, as mentioned earlier. However, do be aware that they should be mounted at least 18 inches from the ceiling and 80 inches from the floor. You don't want people jumping up and grabbing these things. So when you look at them, the suspended luminaires, and these are uplights entirely, they should have a spacing such that you don't get dark spots in the middle. And again, the layout of your space is up to you, so you'll want to determine what's going to look good in your space. For example, are there rows of seating that you want to align with? Then maybe you want to align these guys with that. So then you purchase a fixture which has the right light distribution for your use. And then there's so many examples of these. Many often have a downlight component just for kind of work surfaces or for a decorative effect. Some of them are all down, or they can be purchased with options where essentially they can get flipped upside down. And these can look very nice, especially when they're arranged to work with the seating in the space. So sconces are another one. They start to get into decorative fixtures. They should not project more than 4 inches into a space which is an egress space. If you want them in a residential setting or in a non-egress space to poke 12 inches out of the wall, you absolutely can do that, but be aware that they can be a hazard. Particularly some designs are more prominent than others. And again, they can have any number of light distributions, including a little bit of surface glow, depending on the material. They can be quite decorative, and usually I find sconces work best when there's a whole bunch of them. They kind of set up a rhythm in a space. Track lighting is a great light source for adjustability, and there are basically a zillion different kinds of track lights. They do, unfortunately, tend to show up more in your visual field just because of that adjustability. So choosing the color to either hide into the ceiling, kind of disappear by matching the color of the ceiling, or really going the opposite direction and embracing them and their visibility and making them decorative. So, and most track systems will allow multiple types of light sources on them and luminaire types. So, even the same track can have all these different kinds of light sources, and it usually no problem. Again, there are certain limitations to number of fixtures that are on a given circuit, for example. The most common track fixture is this one. It's called a gimbal fixture because it has a gimbal ring, which, if you know anything about photography, it's kind of a multiple adjustable fixture. It can rotate both in the XY axis and in the Z axis, and you can put all sorts of different lamps in there. The ones we have in the Art Center are an old style screw-in lamp, but or I think it actually might be a bipin lamp. But they used to be MR lamps, which were great for lighting artwork. Now they've all been replaced by LED. And these examples, again, you can spend hours hunting through catalogs trying to get just the right color and adjustability, and then look for the fixture. In this case, the track is actually a rail, which is meant to be more decorative than just the surface-mounted track. And another flavor, these are pendant-mounted rails for your track system. What's clever about this one is they kind of have these interesting bars that span across it. And this is more of a gallery type of fixture. We have a similar one in the Callahan Center, and the nice thing about these, the fixtures are highly adjustable. They are shiny and glossy, but it's a nice fit and finish to this system. So it actually does look pretty nice, I think. And you can see by the blobs of light on the wall that the control of light is very good. Now, the last kind of lighting is architectural lighting, and there's a number of different kind of flavors of this built-in non-decorative kind of lighting. I guess it's sort of semi-decorative. So first of all, a slot is typically along a perimeter of a wall. It can be grazing light, and it can make things appear to float. So, and we've seen this picture before. This is a really tight slot. It does tend to bring out a lot of the materials, the kind of texture of the materials in the wall. Even differentiating it from the light source on the other side of the wall, which is a little bit pulled off, just a little bit, but you get less of a grazing effect and more of a wall washing effect in that location. Or even something like this, where they've cut kind of a slot through the floors, walls, and ceiling and made everything really shiny, which is a little it's making me a little dizzy, but I believe it works in this kind of otherwise boring space. Now, the way that a lot of these work, there's a million different kinds of technologies that exist for a linear slot that is even and uninterrupted. Typically, these are going to involve a linear light source like an LED ribbon or an LED tube, and it has, in this case, they're showing a double reflector. This is a very complicated fixture which has an advantage of throwing light a really long way. But even fixtures in arrangements like this linear strip has par lamps screwed into it. The par lamps are going to have much more throw than any other light source, and that's going to get you a really nice light effect as well. Now, cove lighting is typically used in situations where you want to get light up on the ceiling, but you can have light on the wall or on a recess. There's just any different sort of architectural applications here. Typically, what you see is a wall with a kind of cove construction, and it can be decorative with the profiles or historic profiles. And the light coming out of that is going to bounce up onto the ceiling directly above. These are going to try to throw light as far out as possible, typically, although sometimes the design doesn't warrant that. Like in this case, it's mostly just throwing light up. You can see a bulb is out here, which is not so good. But here you can actually see the light distribution coming out of these. They're really trying to throw light up as high as possible. The big thing that's going to help you throw light up here, besides choosing a luminaire with a good throw, is this distance. The distance from the cove to the ceiling. The higher that distance, the more you're going to get an even light thrown up onto the ceiling surface. So, and then you can have coves that are all organic and hidden and conceal the light source and in fact kind of work with the unusual geometry. Obviously, these are typically going to be LEDs just because they are so flexible. Valence lighting can be pretty similar. You see this a lot in, I don't know, toilet rooms, where you basically have a shield over the light source, and the light it's sort of like a sconce, basically. You can have different light distributions, up or down. Up only, down only, the thing can glow, it doesn't have to glow. And it's often in a situation where you don't have a lot of clearance, so you need some light in the space. You don't want to have an overhead light because that's kind of harsh light. So in this case, it's just a little more subtle. Now, other things that you see are ones we have an example of in class, a luminous panel. And this can be used for signage, of course, but you can do all sorts of interesting backlighting operations here. Even daylighting can come above a luminous ceiling. I just like this drawing because it's so, I don't know, there's just something kind of funny about this drawing. But anyway, you can match electronic light sources with this daylight source by having electric lighting mounted on the ceiling above this. And of course, you'd paint this interior as white as possible. And anyway, these luminous panels can be any number of situations. I actually don't always like it in a situation like this, although it is kind of a cool space. But because it's just so flat that anybody sitting in this space is going to look a little washed out. But a situation like this, where you're going for some decorative lighting, you could have sconces, but those pose a problem because they can't stick out too far. So this kind of situation is actually pretty nice. Or even here, where it's a circulation area, you already want just a massive amount of light in this area anyway. So why not have a funny shape for this luminous panel? It can be a way to produce some interest in larger scale spaces. There are a few other miscellaneous pieces of equipment that we have. For example, fiber optic lighting. As mentioned in an earlier lecture, the light source for this is probably going to be either metal halide or a high output LED. And basically you have a light source in one location and it shoots light through these fibers. And the fibers can be linear or they can be kind of woven into mats for different effects. And this is a great situation if you have, say, a wet location or a location with a high degree of thermal variability. You don't want a regular light source in there, particularly LEDs don't have quite the same operating range as incandescents. Or if you just want a funky ceiling effect that has something that looks, I don't know, like little starlight or interesting fabrics. These provide a lot of interesting opportunity. So some that you'll run into, again, they aren't often hiring interior designers and interior architects to figure out the commercial lighting. Typically, an electrical engineer will just figure this out. But anyway, you will run into it. It's called a high bay fixture or commercial or industrial fixture. Typically anything mounted up about 25 feet or above. And we'll see these in gymnasiums, and they can be point sources like this one, or they can be fluorescent ones like these. And they are just meant to be high output and kind of disappear up into the structure. Now, decorative lighting is just a vast world. I think we spend more money on one decorative fixture than on 20 recessed fixtures, partly because it's an opportunity to really show off the aesthetics of a project. But also it's a spot where you might want to do something custom. It's very easy to do custom luminaires, relatively speaking, because there are just fewer requirements sort of in terms of ergonomics and all that. So, and these can be incredibly variable, just kind of depending on your aesthetic tastes. They can use any light source. They really want to talk about the project. If you're working on a project and your client likes steampunk, to come up with a steampunk fixture. But if your client wants you to use, I don't know, repurposed street lights hanging over a space that are kind of disproportionate in their scale, by all means use those sorts of things. It's really entirely up to you, and can make a space which is otherwise boring, like what looks to me like an escalator in a parking lot. It's suddenly, wow, it's an escalator in a parking lot, but it's a cool escalator in a parking lot. So Finally, let's talk a little bit about sustainable design. No discussion of lamping and luminaires should occur without really talking about how you can kind of do things more efficiently. And one of the things to consider as you're looking at a space, again, if you have a window, think about the luminance ratios for something like a workstation. You'll want to really think about how much light am I pumping into this space. The easiest way to save energy is just not make the space as bright. It's an easy decision. Just like I really don't think there is sustainable design. The only sustainable design is the one you don't do, the project that you don't do. So trying to make it as maximal as possible. As mentioned in the daylighting lecture, you can use photoelectric sensors. The placement of these sensors is actually a real science, because exactly where they are and exactly when they cause lights to go on or off or dim is actually quite complicated. And those photoelectric sensors or motion sensor combined with motion sensors, they are not cheap. And also you want to make sure that they are placed where the task is occurring. And there's so many different flavors of these: open loops and closed loops, and also lighting which turns on and off task lighting. Again, you'll want to think through, is the task going on in, say, my office? Is it mostly reading documents? You don't want the lights switching on and off every time a cloud goes by. So you'll want to tweak the sensors in that location. Whereas if it's a circulation corridor, doesn't really matter. You can probably set those to have a much lower threshold for lighting, light level. So anyway, when you look at an overall building system, lighting is a humongous portion of the overall energy use in the building. And if you think about it, most buildings are used during the day. So why do we need to spend so much energy on lighting? But it's the heat output from those light sources which are causing us to crank up the cooling plant that is a huge impact. So occupancy sensors, again, not quite as simple as just buying one. They all have a threshold and can be tweaked to be on and off during different times of day. For example, it can be an occupancy sensor during the off hours at work, but maybe it's just an on-off switch during the normal work hours. Or you can have it be set to stay on for 5 minutes or 3 minutes or 12 minutes, whatever you want. Things like our bathrooms have an occupancy sensor, and if you've ever been in the bathroom and the light goes out and you can't get your arms to get in the occupancy sensor's range, it's a little frustrating in there. So considering how those work is gonna help you out. You can also circuit to save energy. Again, I mentioned the offset dimming. By having a light source which has the ability to either have partial output, either by turning on and off individual lamps or by dimming certain ones, you can really save a tremendous amount of energy. Just obviously, it has to be a space that has windows in it, or else it doesn't work so good. And the split wiring or offset wiring is the way that this is achieved. So in summary, when you choose a luminaire, you are going to want to start with kind of what's it doing for me in a design sense. Am I just looking for light on the floor? Then downlights work fine. Do I want to increase a sense of space? Well, maybe a wall wash or task or directional light is going to get me either greater sense of the architectural volume or highlighting individual elements against a darker backdrop or whatever sort of effect you're trying to achieve. Then you're going to want to consider functionality. For example, is it dimmable? Is it adjustable? Is it an especially low glare fixture? Then you jump into aesthetics. So once you narrow it down, you can really start to consider the aesthetics of the fixture. Finally, energy usage. Is it a fixture that will offer me the opportunity for saving energy? Does it have greater control of light so that I don't need as many fixtures, or does it have the opportunity to be offset dimmed or otherwise controlled in a manner which will save you some energy?